Let's explore number 24 on the 10B, number 20 on the 12B. We have a frog hopping problem. Now this is a stereotypical states problem. Let's see how we can set it up and solve it. Okay, so we have a frog on the number line. Okay, it starts at 0, and let's just say 0. And if it's at 0, it moves to 1 with probability half and disappears with probability half. So 1, 2, let's say 3, and then 4, right? So over here, there's a half chance it goes to 1. It's probability half, and half chance it disappears. Okay, and let's just see what that looks like. So half times it goes here, half the times it just vanishes. And then for n equals 1, 2, 3, if it's at n, it moves to n plus 1 with probability 1/4, and n minus 1 with probability 1/4, and then disappears with probability half. So for example here, 1/4 chance we go here, a 1/4 chance we go here, and a half chance of disappearing. Now what's the probability the frog reaches 4? Okay, so here this is a very it's kind of a standard states problem. The trick is just set up your equations and solve them. That's it. Okay, so let's say P of 0 is the probability of reaching 4 from point 0, right? The probability of reaching from point 0 is, well, there's a half chance we just disappear, right? And if we disappear, we have a 0 chance of reaching 4. So right, P of anything, what I mean by P of n is, what's the probability of reaching the position 4 from n? So if you're at n right now, what's the probability you're going to make it to 4? And so the probability of making it to 4 from position 0 is half times 0, right? Because there's a 0 chance if we disappear, plus a half chance times P of 1, right? So we're kind of recursively using P of 1 here. Half chance we disappear, half chance, now we're at P of 1, and now our probability of making it to 4 is just P of 1. And then, okay, other equations to set up. P of 1, there's a 1/4 chance P of 0, right? There's a 1/4 chance we go back to 0, and if we go back to 0, the probability of making it is P of 0. There's a 1/4 chance we go to P of 2, and in this case, the chance of making it is P of 2, right? And then there's a half chance we disappear. I'm not even going to write, we have 0. So I'm just going to get rid of this, right? Because there's no chance, we're trying to, this is 0, we can just get rid of it from our equation for simplicity's sake, right? And then we just do the same thing here. P of 2 is 1/4 P of 1 plus 1/4 P of 3. And then we have P of 3 is 1/4 P of 2 and 1/4 P of 4, right? Because there's a 1/4 chance. But what is P of 4 really? I mean, we're at 4. What's the probability we're going to reach 4? That's 1. So 1/4 times 1. And now we just have a system of equations. And ultimately, our goal is to solve for P of 0, right? Because we're trying to find the probability of making it from 0. And these are kind of intermediary variables that can help us solve for P of 0 itself. So from this first equation, let's first separate our equations here. And let's just give ourselves more room. Let's just make that, or not like that, but let's just move this down a little bit so we can get some more space here. Okay. So first of all, we're just going to try and solve for every other variable in terms of P of 0, because we really just care about P of 0 itself, right? We want to solve for P of 0. But you can do this another way. If you want, you can solve for, I don't know, P of 3, and then substitute back to P of 0. It's just more work. Okay, so starting off here, let's solve for everything in terms of P of 0. That's like the most efficient way to go about this. P of 1 is 2P of 0. Okay, great. From here, okay, this one's a little bit harder. Okay, we already know P of 1 is 2P of 0, right? So 2P of 0 minus 1/4 P of 0 is 1/4 P of 2. And yeah, this is a pretty straightforward process. So we multiply both sides by 4. We get the left-hand side is 7/4 P of 0, but times 4, so 7P of 0. And we have this is equal to 4 times 1/4 P of 2. That's just P of 2. And I'm just going to write it on this side. Okay, so now we have our second relation. I'm just going to box this one. These are the relations we're going to be using throughout, right? P of 1 is 2P of 0. P of 2 is 7P of 0. Kind of interesting, right? We have a 7 times, if you reach 1, now we have 2 times the chance. We have double our chance. If we reach 2, now we have 7 times our chance of making it. Okay, now P of 2. P of 2, right? Okay. P of 2, now let's do the same thing. We substitute P of 2, substitute P of 1, and solve for P of 3 in terms of P of 0. So I'll just multiply the entire equation by 4, right? So we can just deal with this. So we have 4P of 2 minus P of 1. 4P of 2, that's 28P of 0. P of 1, that's 2P of 0. So this is 26P of 0, right? And it's also 4P2 minus P1 is also P of 3. So this is P of 3. Right, so I'm just going to write it on the other side just for simplicity, so we can have a consistent way to write it. P of 3 is 26P of 0, right? We have 4P2 minus P of 1, and then we substitute, we see that's equal to P of 3, but also 26P of 0. This is our kind of third relation. And take a look here. P of 3, P of 2. We know both of those in terms of P of 0, and now we get an equation to solve for P of 0. Okay, 26P of 0 equals, or let's just multiply it by 4 first of all, right? So now we have 4 times P of 3, that's 4 times 26, which is 104 P of 0. So 104 P of 0 minus P of 2, that's 7 P of 0, equals 1. So 97 P of 0 equals 1. So our answer is just 1 over 97, right? P of 0 is 1 over 97 from this equation. And it's kind of interesting if you think about it. If P of 0 is 1 over 97, P of 1 we can see is 2 over 97, P of 2 is 7 over 97, P of 3 is 26 over 97. So it's kind of interesting how, we're kind of just increasing our chance as we go. And of course here it's just 97 over 97. Yeah, pretty cool problem of how we solve this. And we just have to, it's a pretty straightforward application of states. You write the equations, you substitute, you solve them. That's all it is for this problem. And I hope you enjoyed this video.